Okay, so sigma notation. This is we're always gonna the way I write these. I always start with k equals 1. You could put other things down there, but it makes it more complicated. Okay, and then up top, the n is going to be the number of terms. So if I had 17 up there, I'd be plugging everything from 1 to 17 in all the integers, which means there would be 17 terms. So this is the number of terms. Okay, and then this part is where you actually build the terms. There will be some sort of a formula there. And so that's going to be dependent on what type of a series you have. If it's arithmetic, then you'll be using that one, right? And if it's geometric, we'll use this one. Okay, so you got to make that decision when you're looking at the series. So writing this one in sigma notation, first thing I want to do is think, is this arithmetic or geometric? So I'm thinking, how am I getting from term to term? Let's see, adding 4, adding 4. So I can see this word has a common difference. That means this one's arithmetic, which means I'll be using this formula. Okay. So let me actually start with that part. So if I'm trying to build a formula for this, well, the first term is 7, the difference is 4, and I'm just going to leave that as n. Now you could actually use this and put this after the sigma, but I want to clean it up a little bit, so I'm going to distribute, because we can simplify it, right? I can distribute the 4. And then I can combine the 7 and the negative 4. Running out of space here as usual. So let's see. 4n plus 3. Okay, so this is what I'm going to use as my term builder. It's a cleaned up version of the 7 plus 4 times the quantity n minus 1. Okay, and then writing sigma notation, it's going to look something like this. Okay, I've got k equals 1. You could actually use whatever variable you want. I wrote n here, but I want to change, since I'm plugging into this, I want that to match up with what I had down there. So I'm going to change this to 4k plus 3. But again, you could have any variable you like, just make sure both of those match up. Okay? And then for what goes on top, I just count up how many terms I have. So I got 1, 2, 3 of them. So that means I'd plug in 1, 2, and 3. And you can always test it out. Plug in a 1. You get 4 times 1 plus 3 is 7. If I plug in a 2, I'd get 4 times 2 plus 3. That'd be 8 plus 3 is 11. That works out, right? And if you plug in 3, it'd be 12 plus 3, which is 15. So hey, it works out. So there's my sigma notation of that series. Okay. So looking at this next one, I'm first thinking as this arithmetic or geometric, and this one I can see I'm multiplying by 3. It doesn't work with addition or subtraction, but it does work with multiplying. Okay. So that means I'm using the geometric term builder. So here's my formula. The first term is 7. The ratio is 3. And there's not much I can do with this. But I can't simplify it. What I see people do that they shouldn't do is this. But that's incorrect, because it's really 7 to the first and 3 to the n minus 1. So you can't combine them. You'd have to do the exponent before you multiply. And since I don't know what n is, it's unknown. It's a variable. I can't really do anything with that. So you can't simplify this. So not the same as 21 to the n minus 1. Okay, so then let's write the sigma notation. And I like to use k, so I'll use k here. And then here I can see there's 4 terms, so I want a 4 up here. And then I'll make this 7 times 3 to the k minus 1. And there we go. Okay, couple more to try. So hey, the terms are changing signs here, but let's see. If I multiplied by negative 2 and then did that again, that would get me from term to term. So this is going to be geometric again. My ratio is negative 2. Okay. All right, and this one's interesting because I don't know how many terms it is. But that's okay. That just means it's an infinite an infinitely long series. So I'll go forever. I'll just put the infinity symbol up top, okay? So then my first term, I'm using the geometric formula from up here, right? My first term is 6. My ratio is -2. And then my exponent is going to be k minus 1. And again, that's not the same as -12 to the k minus 1. So you can't simplify that any further. Okay. All right, one more here. So here we're adding 2 to get from term to term. So this one's arithmetic. Whoops. Sorry about that. Arithmetic. So let's get out the arithmetic specific term formula. Looks like this. Okay, first term is 4. Difference is 2. Got it down to that. And let's just clean this up by distributing and combining like terms. Okay, combine the 4 and the -2, and then I'll have 2n plus 2. Okay, so now I'm ready to write a series. I always like to use k, and this is an infinite series, so just it goes on infinitely, and I've got 2k plus 2. Okay. Okay, these formulas that we've been using for specific terms, these are called explicit formulas, which just means that you can plug, say I wanted the 27th term in this one, I'd plug in 27 for n, right? If I wanted the 100th term, I'd plug in 100 for n. And same here, right? When I've got this formula, actually I've got this cleaned up one here, I can plug in any term value. So that happens in these term builders. So all of the formulas that we've been using for the term builders and the specific terms are called explicit formulas. Okay? You plug in the term number into the formula in order to find the term value. Okay? So here's an example here, right? This is an explicit formula. If I wanted the 7th term, I'll just plug in a 7 for n. And let's see, I got 28 minus 2. That is 26. That's an explicit formula, okay? But there's another type that's called a recursive formula. And a recursive formula is going to be dependent on the value of the previous term. Okay, and I'll show you what I mean in this, this example here. So let's say I just had this formula and I wanted to find the 100th term. Well, I could plug in 100 for n, but then I just get the subscript that would end up being a sub 99. So it'd say 2 times the 99th term plus 3. But I don't know what the 99th term is. Okay? So with these recursive formulas, you have to know the value of one term in order to get started because it's kind of a chain link reaction. So they give us a sub 1 here. So this says find the first 5 terms. Well, hey, I've already got the first one. It's 3, right? So don't forget the one they gave you. So I just need the next 4, okay? So let's try this out. So I've got a sub 1. Let's find a sub 2. So I'm using this formula, and you can actually use it in the same way that you would use an explicit formula. So I'm plugging in a 2 for that little n down there. Okay? And then when I simplify this, I've got that. Okay? Now at this point, if I didn't know what the value of the first term was, I would be stuck. And so that's what I mean. The second term is dependent on the first term. And I know the first term just because it was given here, right? So now I'm going to plug in 3 into that slot, and I've got 6 plus 3 is 9. So my second term there is 9. Okay, I'm going to make a list for my final answer. Okay, so yeah, first term given away. There's my second term, and we can repeat that process. There's also a nice little shortcut. When I simplified this part, here it wound up being a sub 1. So when I'm looking for a sub 2, this part's going to simplify to a sub 1. When I'm looking for a sub 9, This is going to simplify to a sub 8. So this part is always going to wind up being the previous term. Okay, so it's a nice shortcut for these, and you'll see a sub n minus 1 in pretty much all of these problems. You can see it over there, right? So then I'm just thinking, going down the line, instead of actually plugging in the n value every time, I'm just looking at this formula and thinking, okay, it's 2 times the previous term plus 3. So 2 times something plus 3. And for a sub 4, it's going to be 2 times something plus 3. Okay, and I ran out of space, so I'll do a sub 5 up here. 2 times something plus 3. Okay, so something is the previous term, right? So when I'm on the third term, the previous term is going to be the second term, which I already know is 9. Okay, I don't know what to put here yet because I don't know what the third term is yet, but let's get the third term. I've got 18 plus 3, that's 21. So there is my third term. I'll add that to the list up there. Okay, so now in the next term, I'm plugging that in, right? And then whatever this term equals, I'm going to plug that into that slot. So it keeps building on itself. So this is 42 plus 3 would be 45. So I've got my fourth term now, and I've also know what to plug in for my previous term, looking at the fifth term. So let's see, I've got 90 plus 3, that's 93. And there is the fifth term. Okay, and I don't care if you which way you present your answers, but I just did a list there to show them all. Okay, all right, let's try this one. So again, I'm seeing, okay, this is going to end up being the previous term. Okay, so I've got -3 times the previous term plus 2. I already know, hey, there's the first term, right? So second term, -3 times the previous term plus 2. I like to just set these up ahead of time. The only thing that's going to be changing is what goes in the parentheses, because my previous term is going to keep changing. Okay, so in this slot, the previous term is 2. Okay, so -3 times 2 is -6. -6 plus 2 is -4. Okay, and then, hey, -4 goes in this slot. Then I've got 12 plus 2 is 14. And I know it goes here. -3 times 14 is -42. Sorry. Oh, -42 plus 2 is -40. And then I'm going to have 120 plus 2, that's 122. Okay. Okay, found a typo that I had to fix here. So, okay, this next problem, when we have this f sub n minus 1, not f sub n minus, f of n minus 1, this also works out to the previous term, to be the previous term. Okay, so same thing happens over here, right? This is also going to be the previous term. So let's try this out. So they tell us the first term here. First term is 1, okay, that's for free. And we got to find the next 4, right, because we're finding the first 5. So if we're looking for f sub 1, or well, if the first term was f sub 0, the second term is going to be f, I keep saying sub, f of 0, the second one's going to be f of 1. Okay, so I'm going to plug 1 in for both the ends here. Okay, so plugged in 1 in both those spots. And this is just f of 0, which was my previous term, right? My previous term was f of 0, and that the value of that's 1. So then I'll plug 1 in here, and this comes out to 2. So my second term is 2. But just as a little shortcut, that's always going to be the previous term. So I got the previous term plus whatever n is, okay? So I'm going to take the previous term here, and this time it's going to be plus 2 because I've got 2 as my n, right? My previous term was 2, right? Okay, so that comes out to 4. Okay, now I've got my previous term plus 3, right? My previous term is 4. So 4 plus 3 is 7. Okay, so let's see, I've got 4 terms, need 1 more. I'm going to take my previous term plus 4. 4 is my n now. Previous term 7, so 7 plus 4 is 11. So there's the first 5 terms. So it's also built on the previous term. Okay, so let's try another here. This is just going to be my previous term minus 3 for each one of these. So the first term is f of 0, so second term is going to be f of 1, f of 2, f of 3, and f of 4. Already got that first term there, right? So it's always my previous term minus 3. Okay. Okay, so the first term was 2. All right, so my previous term here then is 2. So that's negative 1. So previous term here is negative 1. That comes out to negative 4. Then my previous term, so I got a little chain reaction thing going here. And then you can generate the terms pretty quickly once you get used to that pattern. And there's the first 5 terms, and there's the end of the section. Okay, I will see you next time.